This conference will now be recorded.
Okay, good morning, everybody. So today we've got quite a few things to update everybody on. Hopefully we'll have some other people joining with some news shortly. But the main event of the day is Munir. If I pronounce your name right, Munir, please correct me. He's from Lattice, and he runs a group which are focused on making the FPGAs usable for board management controllers. And so those of you that have been a member of the work group for a while now will know we've got a basic control plane architecture based around the Lattice technology. So Munir is going to kindly go through what they have and what's going on in the OpenBMC and Libre BMC world, in a Lattice's contribution to that, is including some serial channel IP that has been adopted by OCP. So without further ado, I'll hand over to Munir. If you'd like to share your screen,
Sure.
Munir.
Thank you. Thank you, Alan. Thank you, the team here. Let me share my screen.
Let me stop sharing, I guess, a minute. So there we go.
Okay.
Morning, Greg, by the way.
Morning.
Okay, Alan, I'm not sure. Can you see my presentation?
No, doesn't seem to be coming up.
Okay,
Oh, there it
so-
is. Oh,
Yeah.
there it is. Yeah, that's it.
Okay. Let me go to the
If you
presentation
put it in
mode.
presentation mode, then that's
Yes.
perfect. Thank you.
Okay, thank you guys for allowing me to the presentation. What we have been working on is, Lattice has a long history of security, PFR, which is platform firmware resiliency. We're the leader there, but we also, from the FPGA perspective, we have this with the volume leader as well. So we have been looking into BMC, and today BMC and security of the BMC is a big concern from the hyperscalers, especially the cloud service providers. And we have been working with various companies like Ant Micro, Raptor Engineering Solutions, as well as some of the other traditional BMC software vendors, AMI and Free Guys. And today I'm going to talk about like what it is, looks like from FPGA based BMC. Today is everything is ASIC based, and why we think that FPGA based BMC could be a future. And by the way, we are seeing a huge attention for the market as well for this one. So I'm going to talk about that, and obviously some of the side channels that we have and why it is important for HPC, right? HPC architecture that Alan proposed is totally different architecture, right? A traditional BMC may not fit there because of traditional BMCs, because you get all everything in a package, right? There is no, you cannot just choose functionality from that. So we talk about that as well. So let me go through that big details. So the BMC role, just gonna talk a little bit. I think everybody knows about that, but just a BMC role in data center remote cloud management, because this is our focus area is to data center more than enterprise class servers, right? So if you look at typically a BMC is a separate independent system within the server. I had an example here, BMC, typically ASP2600 will be that one, which will interact with the server host. Typically, there is some host IOs happening. So if you look at here, and if you look at the interesting thing is BMC gets a very different power rail, right? BMC, you want to have BMC up and running even though when server is not running. So that's the view that we were looking into that. BMC has several layers, and I have more details on that. The hardware layer, pre-boot firmware, operating system layer, application and services, and who serves what. And then the main purpose of the BMC is typically does fan sensors, LED presence through some LPC channels that actually look at the server health. We say like basically telemetry of the servers, storage, anything like that. The big part is also definitely video, PCIe. By there may be some CSP who doesn't need videos, but that is part of the existing work that is happening. And this is what the big chunk of things that is very important for the hyperscalers is the management, remote host management, and softwares, right? That's the main part because in today's cloud, the data center environment, you're literally talking thousands, hundreds of thousands of servers. Nobody can pinpoint where to go, right? So this is the remote management is a key one. So if I go the second one, we just talked about that. Yes, remote management, servers, hardware, software is important. Uh, what it is typically you have layers of switches that actually goes between there'll be someone sitting in a server or VM who will have a single pane glass of view, overall view of literally probably 10,000, 100,000 servers, and there's a multiple layers of switches where he can go and talk to the different individual servers. He can get notification, he can go as fancy as like, right? Now this is the this is the multi-million dollar business right here. But typically what it does, it goes connects to excuse me, there are many different number of servers. The BMC basically gives a pipeline, right, to the remote management that whoever is working on. From the hyperscaler perspective, I'm sorry. So from the hyperscaler perspective, data center has thousands of servers, and that's the capability. And what it is truly is very simple, right? Hyperscalers, they actually do, rent the VMs, operating system, or the bare metal servers, right? And definitely they have to do go through the constant OS update, firmware update, apps update through the BMC. Anytime somebody, uh, you know, rented a space, they want their new operating system, new BIOS format, all those things. So hyperscale, they have to regularly update this OS firmwares and all those things. And this is what the BMC does very efficiently because the OS update can happen because BMC basically provides you a virtual DVD drive that will be emulated with the BMC and making BIOS to boot up from the virtual DVD. So you want to change the OS system, you basically have to go to the BMC to make that work. Any kind of update, firmware update, everything that is possible to the BMC. Again, as the region I said, that BMC has a separate independent power on system. You can have server up and run, server not running, but BMC is running, right? Which is typically standard. The BMC is running, server is not running, and that's how we can control the servers in the BMC. The problem is that when you have this kind of architecture, right, when the BMC actually has a hookup to pretty much everything in the server, this is definitely is a big challenge from the security perspective. Everybody understands that BMC could be a big security hole because of the way it behaves and because of all the legacy, traditional interfaces that it has to carry today. Because if you look at today, the BMC landscape is all in one package, right? As I said earlier, you don't get to choose what functionality you want and what functionality you don't want. It's always a common package, and that's what we see a lot of issues on the BMC today. So in a system management perspective, if I make it take it here a little bit more details of the BMC and where the attack is happening, right? So if you look at this is the hardware level of the BMC. Typically, ASpeed or Nuvoton or someone else will build this one. It's a basic SoC based today. It has spy flash. It can do the sensor, fans, all of those things. Going in the one more above level, it will be a bootloader because typically BMC runs out of Linux system. So there'll be some microboot, U-boot that ASP would provide that, right? And there's nobody can touch at this point. This is below anybody can see as of today in the standard BMC. So there is definitely a question about what kind of issue we can have here, right? So that's also a big concern from the hyperscalers that we see because this is a black box to us. Up to this point, it's a black box. And then definitely the kernel, Linus kernel is standard one. And then this is what AMI plays in this particular one. AMI or someone who's a BMC application provider, they basically gives you the application, fan control, management, remote accessibility, thermal control, remote media, remote console, IPMI. All those things is typically will be provided by AMI. And this is the portion that is going to be, you can definitely check authenticity of the firmware here that done by the BMC guys, which will be AMI in this case. And typically PFR, which is the platform firmware resiliency, will actually have a authentication mechanism that can authenticate the BMC firmware. So anytime if the hyperscaler wants to change the BMC firmware because they rented out the space, they're taking it back, the PFR can actually tackle that. But the concern is still you have the down below. There is no access here. There's still a concern there, right? Which is why we see a lot of hyperscalers going a separate route. If you look at the Dell, iDRAC is a basically integrated package of security of the BMC. If you look at HPE, ILO, very similar thing. If you look at the Amazon AWS Nitro, is a very similar thing. They have a total system security package that has a BMC plus their own, you know, own developed hardware. Microsoft Calyptra is the same thing. Google is going open security platform. I'm not sure about their hardware, but but it's pretty much everybody is understanding that BMC as a as an independent system can be a big security hole. So they're trying to put it inside the system, right? So if I go to this, this is one of the problem that it's called the pants down critical vulnerability, and I think this has been just the reason I brought it up here is that it has a severity CVSS score of 10 out of 10. This was reported in 2019. Until today, it is still there. Right. This is one of the attack vectors that people with a lower level of accessibility can actually go and take that mid level accessibility through the AHB interface because the vulnerability they found, and it can actually since the BMC is a very is a privileged firmware in the system, it can actually, it can do a lot of damage in a system. So I just said it was 2019. It's just an example. It's just one of the many example. The vulnerability that BMC has today is called pants down today. I don't know why, but that's what the name is. So there's some of the known security issues that we have. Hyperscaler and large entities, they basically require the zero trust solution, right? You're talking about huge lawsuit if you cannot protect your system, right? So they cannot trust anyone, and traditional BMC doesn't have that because, as you said before, that U-boot and everything is black box to a lot of people, right? But that's something that Nuvoton controls, ASP controls, and some other guys controls that. And definitely that's the for hyperscalers and large entities, they're basically looking for a zero trust solution, right? Liability concern is too significant to allow blind trust of vendors, right? We cannot just say, okay, look, trust us, we're fine, we're doing everything that we can, nobody can hack in. And that's what if you talk about Google or Amazon or Microsoft, they don't like it, right? They don't know what existing. So that's one of the things. So looking at a different perspective, the other things that some of the problems that we see in the BMC, because BMC execute a large variety of privileged operation, right? It can update the operating system, it can update the firmware. It has hooked pretty much everyone, every single component in the system, right? A compromised BMC can have access to the host firmware if I spy. Since BMC has access to DMA, it can access to the host memory, get password and all those things that you need to have. There's also complex configuration parsing because when you do all these configuration changes on the fly, because of the hyperscalers typically have to do that because you may rented a space to someone else who changed some of the configuration parameters, and then changing back can be that kind of things can be a hole for the attack. Anytime you have this disable the security settings, and that will, for example, if you have KVM encryption, things like that, if you want to change it, and that happens typically in the hyperscaler environment a lot, that can enable the weak IPM mores, weaken the security. So all those things is basically the vulnerability that we see. Also, like if you look at the BMC today, has a USB port, has a HDMI port, all those things in a hyperscaler environment. You don't need any USB port just to stick to this, right? And the problem is the moment you have those unnecessary interfaces, you need to test fully to its extent to make sure that nothing bad is happening, then nobody can actually get into these interfaces, right? Even though you don't need it, but you still need to check the security of this one. So USB port, like HDMI, because nobody does actually go to the system today and actually look at the data. Things are different from the enterprise class servers, but but again, BMC, as I said, you're getting an all-in-one package, right? So this is some security issues that they have. So what is the core requirement for a secure BMC? Why do I think that FPGA, could be a better option there? And what is the market that we are seeing today, right? So definitely core requirements we all know is to support secure boot because BMC is an independent system. It should support configuration, it should support attestation because all the peripherals that a system has, network card, storage card, or storage devices, uh, you know, memories, everything that the system has is kind of, BMC has to do attestation for that, or BMC or some root of trust. If we consider BMC as a root of trust, then it is. But the problem is, if I don't consider BMC as a root of trust, and I have to separate root of trust module in the system, I still need to go to the BMC because the problem today is that all the server architecture you see, BMC has hooked to everything, right? BMC can talk to the fan, BMC can talk to all the thermal sensors, BMC talk to the storage devices, NIC cards, everything else, server has, right? So the today's architecture, you have to go to the BMC even if you want to do attestation today by yourself through a root of trust device in the server, right? So that BMC has to be the capable of that. BMC today is a huge now because as it says that it's a one in everything package, right? It supports pretty much all the legacy interfaces as well as all the new interfaces that looking at, and then definitely that gives a risk, that gives a we need the reduced risk exposure. We cannot have all the functions enabled if we don't need to, right? Even if we don't, so basically we need to have minimized the attack surface with the modular function. The code base of the BMC to the multiple gigabyte of code base, right? We cannot have huge that much of code base because anytime you have software like that big is easy to attack by the vendor. So we need to make sure that we offer what is needed, not everything that BMC come up with a package, right? And that's where the flexibility of the BMC is coming in. And that's true, right? And we are proposing that FPGA-based BMC, you can choose functions, right? Decouple the SoC hardware from BMC software stack. Basically, again, the same thing. Needs flexible approach to opt out unnecessary functions. Today, you can, in the BMC today, at the runtime, you can actually, choose not to enable some function, but the problem is the function still exists, right? Someone with hacking capability can still, go and enable those functions they don't need, to facilitate their bad intention. Uh, what you're saying is that we need to have, build time. You should have flexibility at the build time, not at the runtime. So today, if you look at this, everything is there in the runtime. You can disable some of the interfaces, but that's not a truly a secret system, right? There's still a security hole that that people can um, basically go after. We need external verification of the BMC image prior to another BMC. This is done today, by the way. But again, as I said, this is done on the application layer level where you can have the PFR to verify the images, but not the root level. We still don't have the zero trust capability where we can trust, we can know everything that the BMC has. This is another one that is not happening today because BMC should never simply fail, right? Let's assume that the BMC application image is corrupted, right? And even if you have two of these application images and both of them corrupted, what that means is BMC will be, halt, right? That is not that's not a possible scenario in a server in a data center environment, right? You cannot have BMC fail and then because that's the last resort, right? BMC fail because if your BMC fails, you have to actually go physically look at the server out of the thousands of servers and actually have somebody there and take out the servers out, make whatever changes they need. So that's something that we don't have it today. If in the traditional BMC, there's no side channel access, there's nothing like that. You can actually make this BMC live. And then at the last, BMC need that root of trust for security. I think most of the enterprise class would like the BMC to be the root of trust. But today, you cannot have BMC as the root of trust on an existing one. Whereas in a PGA base, you can have, it's a modular function that they can add and delete, right? So that's what the whole value proposition here. So there is a couple of things that I talked about earlier, right? What we have today in the market uh, on the FPGA-based BMC. Now, when I did the research, and by the way, we have been working with all these companies. We found out there is two nice solution. One is from Raptor Engineering. They say it's a soft BMC. It's not the full Linux. It's Jeffer based. It's embedded Linux based. Uh, they do, I believe they. So what we have is that we actually had presented this BMC solution. Even the last OCP, I was there. We presented this it's not fully functional. I would say 80% functional. It has pretty much everything that you like to see in a BMC, like fan control, thermal control, firmware upgrade capability, remote access. Some portion of the KVM, it didn't have PCI access, but there's most of the function that it has that I showed in the OCP last year. So we are working with Raptor as well, which is basically this is what the end product is going to look like. We do have, I believe, we have pretty much close to there right now with this Raptor engineering solution. They have we can, I think some of the advantages they have is a dedicated RTOS, not the full fat Linux. So if you want to have hold on to your fan, because in a typical server environment, BMC can take up to 5 minutes to boot up, right? And if you want to hold on to the fan before that, you can basically have an RTOS to control the fan PWM from FPGA based. So they have what Raptor has today is one of our FPGA, which is ECP5. It's about 85K LUTs. They implemented the full BMC functionality there. They still have some LUTs left. I believe some of the utilization is still left. But it's a pretty much working BMC, and I believe they're also selling those BMC to some of the high security minded customers like DoDs, energy sectors, because the problem, they want to see everything, right? So a code base that you could give it to them, which is the open source, that can give the satisfaction to the customers who are very security minded, right? With the traditional BMC, the U-boot portion and the down below, you cannot see, right? So definitely they're selling those things today. We are working with them to make, because this is an ECP5 product, and ECP5 is kind of like older technology for us. So we're trying to work with them with some of the newer FPGA that we have, slightly bigger, to have more BMC functionality. At the end of the day, our strategy is to have BMC class of BMCs that you can pick and choose, right? Let's assume that from the edge, if you look at the edge customers, their requirement is totally different than typical enterprise class customer. The HPC has a totally different requirement than other customers, right? So we're trying to see fit and function, and like for example, some of the newer things that we're seeing, OCP, LTPI, MPST, all the signal aggregation. Today, the BMC doesn't support it. Whereas an FPGA, you can basically drop in this functionality in an FPGA but easy, right? So that's the one we're trying to go after in a model where we can have multiple BMCs serving different markets, right? Edge compute market, hyperscaler market, storage market, security market, network market. Network also has a BMC, by the way. It's a much smaller requirement, but there's something we can serve. We cannot serve with an existing full-fat Linux BMC that we see today, right? So Raptor Engineering is pretty, very much, doing their work today. They do have. We're going to show also this year in OCP, global conference. We're going to show the updated one. This one that will be full functional BMC. As I said, the last year we didn't have on every functional one there. We just had like 80% or 70% of BMC working. So this will be one. There is other companies is working there. So this is what the BMC card looks like. They can have PCI carrier based, or they can have, this is one basically for the development purpose. So if you want to play with the BMC, you can see this is the latest ECP5 parts. You can play with the BMC, and then, but that's the reason they put a PCI carrier card, but you can certainly put it in the motherboard and make it work as it needed. This is the specification that I have. Basically, it's an 85 kilowatts. You can see they have DDR3. This is still slower side because most of the BMC today is a DDR4. And that's the reason we're going after the next generation of the devices. As I said, the CP5 is older device, but it has pretty much HDMI and GPIOs, expander, PCIe, thermal sensors, pretty much everything that we expect to see in a BMC. The few functions is missing. as well as like an HDMI, USB, and a few things. But I think that this is we're still working on. We're gonna show this on the next one. So with that, there's another company is working as well, which is like Ant Micro, and this is the Ant Micro is definitely working on that. We have been we have been looking at as well on Ant Micro, and we engaged recently with Ant Micro, which is part of the Libre BMC initiative that they have. And this is the block diagram. They're still using our ECP5 as well. Part of the region that people are you know people are using ECP5 because ECP5 is all the tool chain. You can find tool chain, internal block images, and all those things you can find in the open community source. I think that's probably the main reason that people choose to go ECP5 device. But this is just you don't have to stay with ECP5, right? We can definitely have some bigger ones. So this is the Ant Micro devices. And
Just on that, back on that slide, I noticed you mentioned KiCad is what, so that's an open source schematic and PCB tool, and you also say DCSCM, so that's a data center security module, which is OCP. Right. Do you know if there's I see Bijan's on. Do you or Bijan know if there's a recommendation to use KiCad if possible in OCP? Keep it all open, including the tools.
Yeah, as far as best practices, we absolutely recommend that.
Okay, because I've been playing with KiCad, and it doesn't have all the bells and whistles of obviously some of the other ones, but it's pretty much getting there. So maybe we'll adopt that for this.
Yeah,
that's a good idea.
I guess, Munir, if you've got schematics that you can provide to us, if your engineers are working in KiCad, then that
Sure.
could also help.
Yeah, I think that's a good idea. I didn't go through that today. It's just an overall view. I didn't build up all those details, but this is just overall industry status today, right? But yeah, I can definitely talk about that more, kind of on that one later on. But I think that's a good idea.
Is there an interchange standard that goes with KiCad?
I'm not sure, to be honest. I think it's. I think they've got sort of porting in and out of Altium. Seems to be the one that they interoperate with.
Yeah, if you want to standardize in something, usually standardize in the interchange format rather than the tool.
Yeah, I was talking with I forget the name, but yes, yeah. Let me talk to them, understand more about this KiCad thing, and
Okay, let's press on. We'll be a bit short time.
Okay, so basically, yeah, this is the when I got the Ant Micro reached it out. This is the ECP5, DCSCI standard connector, which is the support today. They have DDR3 because that's our limitation on the ECP5, right? And then QSPI flash memory, and this is all pretty much the support today from the key from the Ant Micro perspective, right? So let's go to our solution, right? So what is our FPGA-based BMC solution? What is going to look like? So if you look at, we do have a basically it's an FPGA, it's a reconfigurable logic. We can have, so there's a security perspective, right? If you find a vulnerabilities in the future, we can have the hardware vulnerabilities patchable by bitstream update, right? There's no closed tool chains, because everything is open, no binary blobs that we have today on existing ones. So if you look at both Raptor and Ant Micro, you can have, for vulnerabilities to hide within, you can have that fixed. Device fully under the owner of its own zero trust conditions made, because you choose what you're going to put and what you're not going to put, right? So it's not something that hidden from anyone. It's just basically customer like. So it's a full control of its owner. It's a modularity function during the build time, not runtime, as I mentioned here. You don't need USB. You just don't put the USB IP there, right? The other thing is also the PFR, and I'm not sure how familiar with your PFR. PFR is basically a platform format resiliency. There's a NIST compliance. This 193-2. I forget the number, but that what it says is that that BIOS, any privileged format that you have in a system, you should be able to protect it if there is any kind of tampering happening, it should be able to detect it, and if there is anything happening, it should be able to recover it from the bad image, right? That's the NIST compliance. And if Intel took that a little bit further, this is a PFR. PFR is basically gives you the capability to constant monitor any kind of intrusion happens in the BIOS and BMC images. So basically, you put a hook on top of it on the BIOS and BMC spy flash, and then you detect. You basically get the sequence of commands that you're getting, seeing that. And if you see some of the commands are bad commands, because you look at the manifest, if the commands, let's assume that you want to erase the spy flash, then a PROD can actually stop right there, right? PROD can actually make sure that it doesn't happen. There's a lot more details there, but the ask is that we can have the PFR integrated with the PQC. This is the other thing that we were looking also, the post quantum capability, right? The crypto requirement is changing, right? You saw SHA-256, now SHA-384, RSA-3K, RSA-4K, all these are coming, these crypto capabilities. We can actually combine these two as well, because it just, as I said, we do have these IPs for this RSA-3K, 4K. We can combine this as well. So we can have a PFR integrated PQC capability combined BMCs and platform routers. That's a value addition to the FPGA-based BMC. It also can take, because we could consider the platform root of trust, the BMC, it can actually be the platform verifiers or attestation devices, and as well as, there's always some dumb peripherals that you may have, right? The fancy dumb peripherals, sometimes power supply could be dumb peripherals, and they may not have the full attestation capability there, but BMC can actually, FPGA-based BMC can actually tackle that as well. Centralized security policies, and again, in a hyperscalers environment, if you can choose, if you have a cluster of servers, let's assume you have a cluster of 10 servers or 50 servers, you can choose what the policy between the servers as well, right? You can have one server that is acting as a mother server, or the host server, or the master node, and then other servers, based on different applications, right? You can actually do that through the BMC as well. So we also have, enabler of bare metal scenarios. FPGA can encode the trust of cloud providers. It can, if you want to have from one customer to the other customer, the customer to customer B, you're renting a spaces. It can make sure the safe transition. And also like some of the things that LTPI, some of the signal aggregation, all those things that BMC doesn't do today, we can have all those things. So we say this, it's a secure hyperscaler solution that is FPGA. We're actively working in that, and definitely the HPC community is one we're working as well. So if I look at the HPC side, if you look at here, this is our configurable system management controller. Our goal is to go Avant. This is our feature product, which is still not out there yet. As I said, that we're working on today is offering a kind of like not fully functional BMC yet. We're still working on that. This will be a fully functional BMC, but most of the BMC functionality that we see today can be do our existing product. If you look at the DCSCM, just want to touch a little bit. The DCSCM is trying to provide, this has been happening, right? In OCP, understand that there is too much dependence on the BMC, right? BMC is kind of like unknown to all of us, and DCSCM is actually trying to break that paradigm, right? They started with the run BMC, was an attempt to break free the BMC from provider solution. Run BMC didn't go that far, because it just only did the interface. But then I think with this DCSCM, we are seeing a lot more, basically a lot more actions taken by OCP to free up the BMC from standard that what you see today, right? To make sure the BMC is all standardized. I think that's going to happen more and more, even with the DCMHS and all those things. We believe that we're going to see more and more the BMC go towards open BMC functionality. Even if you look at open BMC today, it's not fully, I would say, you cannot just accept as it is. Like the master is very, if you look at that open BMC stack today, right? The main stack, the master stack is very stable, but all the peripherals, you still have to manage yourself, right? So if you still have to go to AMI to provide their peripheral, not the master, the side, and all the sideman channel management and all those things. You still have to go to AMI. Either either someone manages it or AMI manages it, right? So there is still not a fully independent solution that you can just go and pick from the open source community and you can apply. Yes, master can be applied, but when you start adding all these components, you're talking LTPIs, all those things, you cannot just achieve that with as it is today, right? You still have a lot of customization to do. So that's what we say is, and the lattice FPGA will be a better system control than traditional. It will have it doing attack surface. So this is what interesting what the DCSCM, right? We can actually combine more functions to the BMC, right? So if you look at DCSCM today has LTPI, we do have LTPI IP that is, and we're kind of like we also contributed on the LTPI spec, right? Uh, we are LTPI 1.0, LTPI 2.0, DCSM 2.0. We are a very active member there. So we can combine LTPI plus PFR plus power control plus any side channel access that you want, which is ICE40 signal aggregation. We can add everything together that can be, have in a management. We can have protection beyond PFR because PFR only does BIOS and BMC format today. We can go beyond that. It will be a simpler board design if you look at it, because you don't have to have today, if you have DCS symmetric architecture, you have a BMC, you have a PROD, then you have a CMC PLD, and then multiple other things, right? When you combine all those things together, then it's a simpler board design, right? And then you can have, obviously, based on what package of the BMC you take, you can have multiple trust domain, which is very much impossible today. This is additional server to about the multiple trust domains. So that's the value add that we see. So if you look at here, how we look at from the HPC perspective, right? So we believe the one that HPC proposed, this architecture is a very revolutionary architecture, right? Because we see the value, right? Because if you look at typically data travel is a big energy cost, energy problem, right? And here you're not traveling. This is a very, very power optimized solution that we have. The thing is that this will, the traditional BMC is not going to work here, right? Because you don't, all the interfaces that we have, if you look at ICE40 here, this ICE40 is a signal aggregator that's basically, it's an NCSI side channel signal that is collecting to. This is a seamless connection between the lattice and this one. If I put a traditional BMC, that's not going to work, right? Because it's traditional BMC has so many functions that you don't need here. This is we say it's a genius solution. It's a revolution architecture, and we really believe in this one, right? So there's a unique requirement of HPC BMC for a flexible solution, and then we trust that it cannot be an ASIC-based solution. You need to have the flexibility because all these things that Alan is proposing, this is all flexibles, right? Sometimes you can populate this slot, some say don't populate this slots. All this flexible solution that we are looking into HPC needs a flexibility that in the build time, right? You cannot have additional BMC and make it work. So we also have seamless integration of ICE40. ICE40 has basically is a signal aggregation IP that we have in a single wire aggregation IP. So this is a very seamless integration that lattice FPGA can work. It's an independent secure subsystem, the BMC, because our BMC has its own power control and all those things, it will basically totally be independent system. Modularity based on HPC configuration. If you want to choose, you want to put it here and don't put something here, it can be actually, it can optimize based on that it can definitely support modularity as well as optimization that needs to happen because of the HPC architecture, definitely integrated power sequencing. So this is the slides that I took from Alan, and I've been working with him as well. I believe this is my last slide, Alan.
Okay. Great. Thanks, Munir.
Thank
Any
you.
quick questions?
Yeah, a quick question. Maybe I missed it, but how do you solve the serial console port aggregation problem that you talked about at the very beginning?
The question is that how do you solve this problem?
Yeah, how does this change it? How does the lattice BMC change it? Let's say I've got 5,000 servers. I've got a serial console for each one. They're all running at 115, 200. Don't want to drop a single character. How do I aggregate them all into log files?
But that's not the BMC function, though. BMC function is basically each server has one BMC, and then you have a centralized servers or systems that actually collect this information to that. So BMC is still liable for one server.
Right, but the challenge you stated it in the beginning. It's a challenging task as to how to each one of those servers has a serial console that comes out of the BMC that you want to log. It's a complete boot process of the server, right? You don't want to drop a single character. Each one of them is running their serial port normally over the serial port. How do you aggregate them all together?
Right. Good question, Mitch.
Good question. Let me take that because, yeah, I will look into that definitely. What is the name, please? I can.
However, I mean, that's been a big challenge going back for many years.
Yeah,
People try to use
actually,
console consolidators and
actually, on connecting all of these together, that is one thing that. So we needed some sort of control plane, is my view on this, Mitch. So I was thinking of adding some to this last diagram. All right, so that's a good point there.
Yeah, I think I need to know that too because I know this problem, but I think and if it's okay, I'll reach out to you to see how we can look into that together.
Yeah, okay, that's something we definitely need to solve.
Yeah.
And I think this also goes with the composable memory systems of CXL. How do you initialize the entire memory space when it's distributed all over the place in this NUMA? So there are quite a few challenges that the CXL is trying to deal with as well. So we can try and fold that in. Okay, well, actually, Mitch, I might collar you to help me out on some of these pieces, because this is one piece I want to get going on at some point shortly. And Munir is going to help us out with this as well. So we hopefully make some progress. Right, guys, I realise we're quite short of time. I think I lost Ninad, but there's a couple more agenda items. If I just go back onto sharing my screen. So I think next up is Greg. You're still on, aren't you? Would you like to give us? So Greg's, as you all know, Greg's been on a number of the calls, and he's been interested in using the HPCM architecture for various things that he's up to. So Greg's going to give us a little bit of update on things that are happening at his end. So over to you, Greg. We can't hear you, Greg, if you're talking. Your microphone was off of mute. No, we can't hear you. Such is life. Still can't hear you, Greg. Okay, while Greg's trying to fix that, I'll give you an update on the conferences. So we've got the Flash Memory Summit coming up, and in literally a couple of weeks. And I was asked if I would like to do a Meet the Experts table again this year. And long story short, I'm actually on the Meet the Experts table. CXL has got two of them. One is for applications and HPC. And so okay, we can hear you now, Greg. Just this conference. So basically, I've got a Meet the Experts table at Flash Memory Summit, which is the 8th to the 10th of August. If any of you guys are going to be going to Flash Memory Summit and you want to join me, I'll be basically I'll have a laptop and an iPad and just be showing people what we're up to. Take the opportunity and I'll do a little blast out on LinkedIn to say that I'll be there. So we have a little opportunity to educate a few more people on what we're up to. Okay, Greg, I think we can hear you now. So back over to you. Greg, I thought we could hear you. Your microphone's on mute.
Okay, about fourth time lucky. How's that?
There you go. There you go. I can hear
you.
Oh,
super. We've been building a skunkworks to solve a new generation of problems in the aerospace space, amongst other things. And long story short, it's all really about AI enablement, being able to solve old problems in new ways. There are so many problems that are inadequately solved as far as our customers are concerned, and with the neuromorphic, self-evolving neural network technology that we've been developing over the last 15 years, we've managed to convince them to let us have a crack at solving those in a very kind of agile, skunkworksy manner. You're kind of all wondering, why is that relevant to HPCM? Fundamentally, the AI is very compute heavy. It is compute heavy in terms of training. It is compute heavy in terms of deployment in many respects, especially when there's training at the edge, so-called transfer learning or federated learning. We've had a good look around the market at lots of other solutions, and long story short, we've come to the conclusion that we'd really like to try and back the HPCM project as a kind of first adopter and engineering support partner to be able to make HPCM a reality for our own use, fundamentally. And talking with Alan some time, of course, and attending these. Yeah, we're really keen to see how we can support the program in terms of resources and also just being essentially a good user. And we've got a plan to build out a significant cluster for our training purposes, and also potentially roll it into some of the products that we're working with. We're actually backed by one of Europe's largest OEMs, and looking forward to seeing how we can make this happen and really build a better platform for AI. I think we feel that we've really hit the limits of the x86 pizza box model, and it really is time for something better. And likewise goes for the aerospace world. VPX, terribly old standard, even though it's come through various iterations like SOA. It's not really fit for purpose for this next generation of applications. Yeah.
And I guess you can't mention this particular thing.
Well, there's only two big defence OEMs in Britain, and it's one of those two. So I'll let you guys figure it out for yourselves.
Okay. Well, we might be hearing.
But there'll be a public announcement sometime in the next few weeks. So yeah, you'll hear about it.
All right, thanks for that exciting update. So yeah, I've been working with Greg for a while now on this. So things should be coming together, not in the not too distant future. Which
Probably
is great.
by our next call, in fact.
Yeah. Thanks very much, Greg, for working with me, and looking forward to getting going on this.
Yeah. So likewise, really excited about it.
Yeah, great. Okay. Thank you for that update. And I've got another update on the HPCM, our development plans. I had Nanad was on the call, but unfortunately, it looks like he probably had to drop. So those of you that have been on the recent calls will know that we've been looking at the thermal cooling solutions for the module, specifically for the 1 kilowatt processor, and we were considering this innovation which the University of Illinois in Urbana-Champaign have done with this conformal coating, coating the board with a small piece of insulation and then coating it with copper, and that being a far more efficient thermal interface for the water flowing across the top. So Nanad is a professor that leads that, and I've met up with him a couple of times, and also if you remember Progress Analog, the load slammer company, Roger Beeston has been on a few of these calls, and his colleagues helping us out over the last few months and years. And so the three of us got on a call together. And so we'll be folding Greg into this as well, is what we're trying to do is actually, not worry too much about the actual compute side of this at the moment. We got to make sure the design of the infrastructure piece, the module design itself, and the wall and all the cooling, the thermal management in cooling is in good shape. The nice thing we've got here is Nanad has said he's got a number of projects going. He's actually actively working with OCP at the moment, and he says he should have some research funding to help us actually build a module with this conformal coating on it. The nice thing here is that we're actively hoping to design a Xilinx AMD based FPGA module, one of their biggest FPGAs, if not their biggest one. And Roger is going to build a power adapter package that can actually provide the load slamming of the power supplies on the board. And we are going to conformally, so it will be in that footprint of the FPGA, so it'd be part of the normal design of the module. And we'll conformally coat that, we'll get the lid on it, we'll make some infrastructure of a mini sort of wall in a benchtop scenario, and we'll be able to test the thermal and power delivery using Nanad's cooling technology. So, and he will be able to, contribute his researchers and a bit of money maybe towards building this.
Well, I think we may be able to coat a board. We've just spent 300 grand on a new printer, and part of the premise is that it should be able to conformally coat boards. So we may actually be able to do that in-house in a couple of months.
Okay. Well, like I said, we'll fold you, Greg, into the NAD, and we can look at the various approaches here. So it's nice. We're really beginning to get to the point where hopefully we can have something physical to transfer. The only other thing in the last few minutes that I wanted to update you all on as well was I've been playing with the actual redoing the model. I've had some various pieces of feedback. So I have made the module slightly wider, and it's probably going to be about 115 come when I'm done here. And I'm looking at how do we mechanically make sure this is mounted to the wall. So I'm looking at a few other aspects of making sure all the pieces are in place. And we've got enough based on Callum's feedback from Cool IT last week or last couple of weeks ago. I'm making the module wider to thicken up some of the copper in the spacing between the E3 modules that we're trying to cool. So I'm quite happy that we've made a bit of progress there. Actually, that I feel a bit more confident about that overall design. And so things moving nicely in the right direction. Any comments or questions on all of that? Okay. All right. Well, everybody. Well, thanks for joining us today, and I look forward to. Well, actually, just to double check, next Tuesday and the Tuesday. So the next meeting is actually on Tuesday the 8th, which is the Flash Memory Summit. I should be able to attend. I'm thinking I can attend before the conference kicks off. So hopefully we'll have the regular meeting in a couple of weeks, but I'll keep you posted. Okay, everyone. Thanks very much. Thanks, Munir, for your presentation. And
thanks, guys.
Thanks, guys.
thank you.
Thank you.
Bye.
Thanks,